Hey, hello. Hello. My name is Vincent Sitampalam and matrix number is C8H0100. Okay, so today I'll be explaining about this in TLU version, this for software. Okay, so as you can see here, this is the assignment that was given to me. So today I'll be explaining about microprocessor and microcontroller, which is assignment 2. Okay, so as you can see here, it's used to LPC1768 and LM35 as temperature sensor. This temperature sensor controls the motor. So note that in one into info inputs used to control the motor spinning direction as table 1 and 2 explaining. So this is the table. So now let's go to the coding. Okay. So now as you can see the coding, this is the coding that I did it for this assignment. So now let's go to first pin cell 1. As you can see here, pin cell 1. This is pin cell 1. So what I use is for pin cell 1 is 14 and 16. So 14 and 16, pin cell 1 is here 14 and 16. So this selects the analog and digital converter 0.0 and 0.1. You can always refer to the user manual. So this is from user manual, so which is 0.23 and 0.25. So this will be the voltage that I can control in ADC is AD 0.0 and AD 0.1. So for the next part is pin cell 4. This is pin cell 4. So you can see this is pin cell 4. So I'm using 4 and 6. So if we go to 4 and 6, this is 4 and 6. So I enable 4 and 6. So 1.3 and 1.4. So the port that we can get the PWM output is in 2.2 and 2. So and next is the interrupt is in pin 10. This is interrupt. This is the pin 10 for the counter, and also the counter is on this port. This GPIO port 0FF. So now let's run it. Uh, there's no warning and debug it. Okay, so this is the logic analyzer where my PWM is on port 2.1 and 2.3, as you can see here. Sorry, 2.2 and 2.3. So this is 2.2 and 2.3, while the port of counter is on zeros times FF. So now let's run this query. Okay. As you can see here, this is in 0, which is that's none because I didn't add the value on a analog input, which is a in 0 and a in 1. If I add in some value, as you can see here, wait, let's say I add 5 and here also 5. Okay, so now you can check the this part, which is AD to DC channel data, which converts the input into hexadecimal. As you can see here, this is the input. So now if you see the graph, there will be some value. So this is the value for power. This is the duty cycles. The both duty cycle will be the same because I add the same value of voltage. So this indicate the speed of the motor. If I increase this to 1, then the duty cycle will increase in port port 2.2. So now as you can see this, so as you can see the duty cycle increases. So thus this makes the motor in motor 1 will be increased. So for the next part is the counter is until 4. How to reset the counter is I set the counter in port 10, 8, 9, 10. This is the port 10. I press this counter, and then it will start from 0. When I keep it back, it will remain the same. And if I press again, it must start from 0. So this is the reset button. So now you can see the 8 LED. I mean the 8 LED the counter, which is in binary form, as you can see here. If I press this, then the counter, I mean the display on 8 LED must be 0. So if I press this, see? So it will be same as if it's 1, then it should be 1. If it's 2, it's 1 0. Then it will go until the last counter. So that's all from me. How I hope you understand, and thank you.